Today we're looking at notes MM-2, radii, work backwards. So given this graph, write a possible equation for the function graphed below. So we're going to start with r, which means roots. So what roots do we have? Okay, so we have the roots -1, 2, 3, 4, and +1. So -4, 0, and +1, 0. Okay, and then A, asymptotes, VA, more specifically, we have 1 at x equals -2. Okay, T for tangency, we have no tangency, not togetherness, none. Okay, for togetherness, we do have togetherness at x equals -2. And right here we're going to pause. Okay, because remember this deals with numerator, denominator, numerator, denominator. We are going to get some skeleton of our possible equation. Okay, so to have a root here and here, of course, we're going to have the factors x plus 4 and x minus 1 in the numerator. Okay, so check, we've taken care of that. Then to have this vertical asymptote at x equals -2, we will have the the factor x plus 2 in the denominator. Okay, so there's no tangency. That means that we have no, remember, numerator, denominator, numerator. We're back at the numerator. We have no squared factors or even term, even exponent here in the numerator. So, yep, we're good. Okay, togetherness. So we do have togetherness at x equals -2. That means this must be squared. Okay, it could even be raised to a fourth. We're just going to stick with squared. Okay, so then we need to clean up before we go any further. So just remember, whenever you have the RATT finished, we're going to pause and we're going to clean up. So we are going to FOIL this out. We would get y equals, multiply, you'd get x squared plus 3x minus 4 in the numerator, and then in the denominator, when you multiply the quantity x plus 2 times the quantity x plus 2, you would get x squared plus 4x plus 4. Okay, and then we're going to talk about E, so in behavior. All right, so in behavior, we do have a horizontal asymptote at y equals 3. So let's think about this. For the horizontal asymptote, that means that if it's y equals 3, if it's not y equals 0, our possibilities are this equals some integer value, or it equals, well, not necessarily an integer, but it equals a value, or it equals 0. And when it equals 3, when our horizontal asymptote equals 3, that means that our degrees, are the same, and we take our coefficients and divide them. So that must mean that we're going to have 3 over 1, or something that simplifies to 3 over 1 as our lead coefficient. So of course you could put 12 over 4, you could put 6 over 2. There's many options, but I just want to keep it simple. So I'm going to put 3 out in front, and just don't forget, we will have to distribute through. So we're going to do that here in a second, distribute through. So we've taken care of the horizontal asymptote. Okay, so let's go ahead and distribute through and clean this up one more time. So y equals 3x squared plus 9x minus 12 over x squared plus 4x plus 4. Okay, so here we've taken care of that. Now we're going to talk about y-intercept. So on the graph, we do have a y-intercept. It's at 0, -3. So from this point on, we're pretty much checking. So I'm going to put another line so you clean up here, and then from this point on, it's like a check only. Oops, let me write it in green like this one is. If you've done everything properly, it should all check out. Okay, there shouldn't be anything else you have to change. From this point on, it's like a check only. Okay, so our y-intercept is 0, -3. Let's check it. So if you plug in 0 for x, 0 for x, 0 for x, 0 for x, will our y-intercept be -3? Well, look at that, it sure will. Okay, so we're good there. And last thing crosses EBA. So yeah, we definitely crossed the EBA. It looks like it's right here at -1, 2, 3, 4, 5, 6, 7, 8, -8, 3. Okay, this is another situation where we are going to have to check. Okay, so let's verify that is -8, 3. Okay, let's come up here for some space to work. All right, let's come up here and check. I'm going to use, I'm going to use pink. And let's check this. Okay, I just don't want to confuse. I want to use a different color. So 3 equal to our equation. So 3x squared plus 9x minus 12 over x squared plus 4x plus 4. Okay, so put the 3 over 1, distribute the 3 into all three terms in the denominator. So that would look like 3x squared plus 12x plus 12. I'm trying to write teensy tiny. And then all the terms in the numerator will stay the same because you're just multiplying by 1. So then our 3's eliminate. Bring over this 9, so we would have 3x equals, bring over that 12. Of course, it's -24. So x equals -8. And that checks out. That checks out. Our coordinate is -8, +3, excuse me. So here's some notes to finish today off a tad. Okay, so for this part, okay, I'm going to use orange because I want you to remember this. Show work for the checking no matter what. Show work no matter what, even if it fails. Meaning even if you don't have that cross EBA, you need to verify that when you set the asymptote, whichever it may be, or oblique or horizontal, set it equal to the function and show that it's not a true statement, because that would prove that you don't cross the EBA. So show work for this no matter what, even if it fails. You have to prove that it works. Okay, and then similarly here, make a note here, if there's an oblique asymptote, okay, show long division. So similarly, we have to prove. So take your equation and divide. If you have an oblique asymptote via the graph, you see it via the graph, you get the equation from the graph, then when you believe you've cleaned up and you have your final answer, do that long division and make sure the equation you get from the graph matches the equation you get whenever you divide your equation. So another thing I want to point out, last thing, this keeps popping on me, okay, is, so everything in orange are definitely things you need to remember. Okay, last thing here is you have two answers. Okay, the factored version, And then I guess we can call this clean. I don't know. It's clean is in the eye of the beholder, right? So clean, I don't know. Would you call it clean? Simplified? I guess it's in the eye of the beholder. But this is the non-factored version. So no factors. Non-factored. Okay, but you will have two answers. Underline, 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 underline. Look at that. I'm just going to finish it off. Two answers. Exclamation point, exclamation point. All right, so cool lesson today. I hope you enjoyed it. That's it.